So a lot of times in this course, we're going to need to assume that something comes from a normal distribution. And that's going to be such an important assumption that we actually need to be able to test that assumption. And there's going to be really 4 different ways that are available to you to do a test of normality. Now, by say test, some of these are a little bit subjective. The first one is a histogram. That's one test of normality. Another one goes back to stuff that we did when we started talking about percentiles and deciles and things like that, and that is outliers. If you have more than one outlier, chances are you don't have a normally distributed population. The new one in this section for us is going to be something called the normal quantile plot. Normal quantile plot. Sometimes called a QQ plot. You'll see this described on page 298. And we'll look at that in a moment. And the last one, which, some version of this is available in StatDisk, is the Kolmogorov-Smirnov test. Kolmogorov-Smirnov test. Or if that sounds too Russian for you and you're vaguely upset about the elections, then you can do something a little bit more ethnocentric with the Ryan-Joyner test. But both of these are different tests for whether or not something is a normal distribution. So let's take a look at the backside of handout 1 from earlier and some of the data sets in Triola. This one happens to be the weight of orange M&Ms. So it'll be interesting to see where he got that data. I think he actually probably weighed it with a really good scale himself. He is pretty fanatical about getting good data. So let's take a look at a few things here. The first and easiest way to try and decide whether or not something is a normal distribution or comes from a normal distribution is to look at the data. What do you think? Does this look like it has a normal shape? Yeah, looks pretty good. Now, I'm not looking at the original data set itself, but you could also look for some outliers. In looking at the box plot here, remember these are the 2 extreme values, and then this is quartile 1, quartile 1, quartile 2, the median, and quartile 3. That looks pretty symmetric in there, so a lot of your data is nice and symmetrically located and concentrated around its center. So things are looking pretty good. Let's discuss the normal quantile plot. What you're going to do in the normal quantile plot is plot the percentiles of your data against the z-scores that you can get from a z-table. And let's flip over to page 298. What you'd like to see when you do this plot, if you have some normally distributed data, is you'd like to see this data kind of scattered nice and randomly about a straight line. That's what you're hoping for. If you do have some kind of a random pattern around a straight line, then yeah, it's looking more and more like a normal distribution. In this case, you can see what a normal quantile plot looks like for some normally distributed data. Of course, not everything is nice and normally distributed. If there's patterns in here, in terms of going up and down or something other than random fluctuations around a straight line, chances are it's not a normal distribution. We can see that with the uniform distribution. If you did a normal quantile plot for this kind of data, notice that it curves nice and neatly up above and down below. There's something more to this pattern other than random fluctuations about a straight line. If that's the case, you're not looking at a normally distributed set of data. How about this one down here? Do we have to look at that too far to see that this isn't nice and neatly tucked around a straight line? No. That one fails what's called the interocular test. You know what the interocular test is? It smacks you between the eyes. It's like, no. It's not a normally distributed data set. So this one should really be striking that it's far away from normal. Okay. The Ryan-Joyner test, the Kolmogorov-Smirnov test, we'll get to those in a minute. Let's just look at a couple quick ones from this section. Get your thoughts on both of these. So we'll start with problem number 6. So what we have in problem number 6 is the normal quantile plot for the body temperatures. We can find this ourselves. This is data set 3 in Appendix B. So maybe we'll go to that in a minute when we flip over to StatDisk. What do you think? Do these look like they're random fluctuations around that straight line? Is there any pattern to these that's concerning, or are they just kind of nice and random around the straight line? Is it normal or not? Yeah, I'd say this one looks pretty normal. Yeah, it doesn't look like there's any patterns there that are concerning to me. So, yeah. In fact, that's what the author's conclusion is as well. Points are reasonably close to a straight line pattern, and there's no other points, no other pattern that is apparent here. All right. Let's move down to problem number 8, flight departure delays. We'll dedicate this problem to United Airlines. Normal quantile plot for flight departure delays. What do you think? Do we have to look at this one too long? Normal or not normal? No, not normal. Definitely not normal. So, and like I said, being a normal data set is going to be a part of our assumptions that we're going to use in some of our work later on. So being able to determine this is really, really helpful. All right, let's open up StatDisk. You can navigate your way to the data sets, 12th edition, and then the ages of Oscar winners. We've got 2 ages here. Let's do some analysis of this data. If you want kind of a shotgun approach, we can do the explore data, which is going to give you descriptive statistics, ton of stuff here. We'll do it first for the actresses. You have your choice here. You can do actresses or actors. It'll tell you which column of data you want to work with. And then click evaluate, and we should get a lot of stuff here. So you've got the mean, the median, the mid-range, the root mean square, the sample variance, and the sample standard deviation. We can take a look at this now from several different points of view. First of all, looking at the histogram, does that look like a normally distributed data set? No, it's skewed to the right. If you look at the normal quantile plot, yeah, there's kind of a pattern here. Almost looks like a parabola here rather than a nice straight line. So again, it fails to impress us as being from a normally distributed population. It's going to be skewed in the direction of the tail. So this will be skewed to the right. So thank you, though. If you want to get a little bit more specific, then what you can do is a test. And we'll understand a little bit more about this later. But if you go to data and then go down to normality assessment, then this will allow us to a little bit more objectively determine whether or not our data appear to come from a normal distribution. So again, click on data, then scroll down to normality assessment. It's going to ask you what column do you want to assess. We can do actresses. You click evaluate. Now a lot of this output won't make much sense to you, but one thing that you can appreciate is that it's telling you to reject the normality assumption, that it just doesn't make sense for us here with this data set. It seems to go a little bit outside of what we would believe. So I'd have to consult with Triola to find out which actual test he's implementing here. Like I said, there's a couple different tests that you can make, but usually what you do is you use several of these things together. You don't just look at one piece of evidence. You look at the histogram, you look at Kolmogorov-Smirnov test, you look at the normal quantile plot, and you make kind of an overall judgment. You don't necessarily base it just on one piece of evidence. So you look at several. Okay, on the back of your handout, continuing there, let me go back here. Got one last one. Again, this is data that you can get from Triola. What I'd like you to do is take a look at this and then talk with a neighbor. Decide whether or not you think this is a normally distributed data set. Would you say thumbs up or thumbs down on this one, yes or no? I'll give you a minute to discuss it, look at it, etc. Yeah. It's like Family Feud, right? Good answer, good answer. No matter how stupid it is, it's a good answer. It doesn't have this data set here. Or am I missing it? Does it have the earthquake data here in this? Not seeing it. Oh, thanks. There we go. Earthquake measurements. All right, so what's the consensus opinion? Normal or not normal? Not normal. And again, it's kind of a combination of two things. First of all, the histogram doesn't exactly look normal. And then as far as the normal quantile plot, there's this gap, which is a little bit disconcerting. You know, that's a little unusual to see in these types of plots. So there's a little bit something more going on in this data set other than just a nice normal distribution. Now again, you can test these things in StatDisk, so it's kind of convenient. Let's go to Data, Normality Assessment, and I'm trying to remember if this was the magnitudes or I think it's, yeah, I was going to say, I think it's depth. So if we evaluate it here, you see the output that we have on our handouts, and it's telling us to reject the normality at a 5% significance level and at a 1% significance level. We'll talk about a little bit about what these mean in the next section. But for now, what you should be able to do is assess a piece of data or assess a data set. It's whether it's normal by looking at a combination of things. Should have at most one outlier, should have a normal looking histogram, and a more or less straight line normal quantile plot. So those are the three things that I would hold you responsible for. We're okay with those? All right. Hope you enjoyed section 6.6. For homework, and again, my apologies because I know it is a holiday weekend. Try problems 1 through 7. And 11 and 13.